Early humans were carrying fire for over 1 million years before they knew how to make it. Not controlling it, not understanding it, just keeping it alive. Hauling a smoldering branch pulled from the edge of a wildfire across open ground and tucking it into the back of a cave. That was the relationship. Not mastery, not invention, custody. The question that study after study keeps circling but rarely answers directly is, why bother? Fire kills. It spreads unpredictably, it burns through everything, and for most animals on the savanna, proximity to it is a death sentence. So what was it about early hominins that made them willing to get that close and then go back for it again and again across hundreds of thousands of years before they had any real grip on what fire even was? The answer turns out to have less to do with courage or curiosity than with something that was already wired in long before the first branch was ever picked up. And a brand new 2026 study just pushed that picture back nearly 1.8 million years. So here's what this video is actually about. We talk about fire as this triumphant human invention, the moment our ancestors became something more. But the real story is messier, stranger, and honestly more interesting than that. Because early humans were using fire long before they had any idea how to make it. And the reason they were willing to get that close to it in the first place may have nothing to do with bravery or curiosity. It might have been something much simpler. The fear had already been switched off. Let's go back, way back. Scientists have uncovered compelling new evidence that early human ancestors, likely Homo erectus, were deliberately bringing fire into Wonderwerk Cave in South Africa as far back as 1.79 million years ago. That's not a typo, 1.79 million years. To put that in perspective, that's nearly double the gap between the first fire makers and the internet. Previous research had established fire use inside Wonderwerk Cave at roughly 1 million years ago, but researchers reached deeper into the cave's stratigraphic record and found burnt animal bones dating to a period between 1.07 and 1.79 million years ago. Now, the obvious question is, how do you know those bones were burned by humans and not by a lightning strike or a grass fire that wandered in? The location of the burnt material plays a key role in the study. The fossils came from deposits at least 30 meters inside the cave, and natural grass or bushfires would have struggled to reach such depths. Researchers argue that this distance makes accidental burning from wildfires unlikely. And it wasn't a single event. Burnt bones appeared in distinct clusters rather than being spread evenly throughout the excavation area, suggesting repeated burning events occurred in specific parts of the cave over long periods. So something was bringing fire in there, again and again. And here's the part that gets really interesting. The way researchers found this evidence at all. They didn't find a hearth. They didn't find charcoal. 30 meters inside Wonderwerk Cave, in a layer of sediment between 1.07 and 1.79 million years old, researchers found bones that, when illuminated with a narrow-band blue light, and viewed through a long-pass red filter, emit a faint but distinct luminescence. Bones that were never heated do not. The physics is straightforward. Thermal alteration changes the crystallographic structure of bone mineral, and those changes shift the wavelength at which the material re-emits absorbed light. Burned bone glows differently under specific light. Unburned bone doesn't. Paired with established chemical tests, this luminescence approach let researchers flag burned bone with far more confidence than visual inspection alone allows. And the method is portable and non-destructive, meaning it can be applied to large fossil collections without damaging the specimens. That matters beyond just this one cave. It means there could be fire evidence sitting in museum collections right now that nobody has identified yet because we didn't have the right tool to look for it. The findings from Wonderwerk Cave strengthen evidence that hominins were managing fire much earlier than once thought, and the study introduces a fast, non-destructive technique for identifying ancient burning that future research at other archaeological sites could use to help refine the timeline of early fire use across Africa and beyond. The real timeline of human fire use may go back further still. But here's the thing. None of that evidence tells us that these early humans actually understood fire. It seems likely that early Homo was only able to acquire fire from natural, mostly seasonal wildfire resources and bring it to their occupation sites. They were fire keepers, not fire makers. The evidence points to fire gathered from natural sources on the surrounding savanna, such as lightning strikes or wildfires, and once gathered, that fire appears to have been carried into the cave and kept alight for a time before it went out. True fire making, actually striking sparks or drilling wood, wouldn't arrive until around 400,000 years ago. That means there was a gap of over 1,000,000 years between tending fire and creating it, which almost nobody talks about. So if they couldn't make it, why get near it at all? Why carry a burning branch across open ground? Why go back for it repeatedly over hundreds of thousands of years? This is where the chimps come in, and stay with me here because this is the piece that reframes everything. Savanna chimpanzees at Fongoli, Senegal, appear to be able to predict the behavior of wildfires of various intensities. Although most wildfires are avoided, even the most intense fires are met with relative calm and seemingly calculated movement by these apes in an arid, hot, and open environment. Primatologist Jill Pruetz studied these chimps closely, and what she observed was not panic. It was something closer to assessment. The researchers interpret the chimpanzees' behavior to the wildfires as being predictive rather than responsive, in that they showed no signals of stress or fear, other than avoiding the fire as it approached them. Pruetz described watching the fires burn so hot they were taking out trees in seconds, and the chimps just standing there, calm, repositioning themselves ahead of where the fire was going to move. They were experts at predicting where it was going to go, she said. And not only were they calm around the fire itself, in burned areas, chimpanzees spent more time foraging and traveling than in unburned areas. They understood on some level that a burned landscape was a resource. The undergrowth was gone. Food was exposed. Moving through it was easier. This flips the whole brave humans conquering fire narrative. Early hominins weren't necessarily drawn to fire because they were bold or curious. They may have been drawn toward the aftermath of fires, the scorched earth, long before anyone was brave enough to pick up a burning stick. And the cognitive groundwork for tolerating fire, for reading it, for not running from it, may predate our genus entirely. Researchers wrote that the control of fire by humans involves 3 cognitive stages: conceptualization of fire, ability to control fire, and ability to start a fire. And according to Pruetz, the Fongoli chimpanzees have mastered the first stage, which is the prerequisite to the other 2. So the real leap wasn't grabbing the branch. It was already not being afraid of the fire in the first place. Now, once hominins did start making fire, once they crossed from keeping it to creating it, the sophistication that followed is genuinely underappreciated. Take Neanderthals. For decades, black mineral blocks found at Neanderthal sites in France were assumed to be pigment, body paint, decoration, symbolic art. Several Neanderthal sites in France have yielded large numbers of small black blocks, and newer research argues Neanderthals used these manganese oxides in fire making, not as previously thought for coloring. Here's why that matters. Combustion experiments and thermogravimetric measurements demonstrate that manganese dioxide reduces wood's auto-ignition temperature and substantially increases the rate of char combustion. Manganese dioxide added to wood shavings or other tinder increases the efficiency with which the tinder captures a spark and lights. Starting a fire using sparks from flint without a metal striker is not as easy as it may seem, but manganese dioxide has a significant beneficial effect. Neanderthals were essentially carrying a chemical fire-starting additive. They had figured out that a specific mineral, ground into powder, made the whole process dramatically more reliable. The actions involved in the preferential selection of a specific, non-combustible material and its use to make fire are not obvious nor intuitive, and the knowledge and insights suggested by Neanderthal selection of manganese dioxide are surprising and qualitatively different from the expertise commonly associated with Neanderthals. And then there's the Zhoukoudian story, which is a useful reminder that even scientists get fooled. Zhoukoudian, the Peking man site in China, was the classic textbook proof of early fire use for decades. The ash layers seemed clear. The case seemed closed. Then a 1998 reanalysis suggested that some of those ash layers were actually water-laid sediments, and the bones and stones were more likely charred by naturally occurring fire than by human activity. The debate is still not fully settled today. It's a good example of how hard this evidence actually is to read, and why the new bone luminescence technique from Wonderwerk matters so much. It gives researchers a cleaner signal in a field that has historically been full of noise. There's one more piece to this story that deserves a mention, because it shows that using fire as a tool wasn't even uniquely hominin. Australian raptors, black kites, whistling kites, and brown falcons have been documented intentionally transporting burning sticks in their talons or beaks to spread wildfires and flush out prey. This was long-held Aboriginal knowledge that science eventually confirmed. The point isn't that birds invented fire use. The point is that the logic of fire as a resource, something that clears cover, exposes prey, creates opportunity, is old enough and obvious enough that multiple lineages figured it out independently. Which brings us back to where we started. Early humans didn't rush toward fire because they were uniquely brave or uniquely intelligent. They approached it because the capacity to read fire, to tolerate it, to see the opportunity in it, was already there. Inherited from a lineage that had been navigating wildfire landscapes for a very long time. What changed slowly and over an almost incomprehensible stretch of time was the decision to stop waiting for fire to happen and start making it themselves. And even then, they kept refining it, adding manganese powder, developing techniques, turning a scavenged ember into something they could summon on demand. The 2026 Wonderwerk findings pushed that whole arc back nearly 1.8 million years, and with a new detection method that may reveal evidence we've been walking past in collections for decades, that number could move again. If you've ever wondered how the other things we take for granted, language, cooking, shelter, went through the same kind of slow, strange, non-linear evolution, there's a lot more on this channel worth digging into. Drop a comment with what you think the hardest cognitive leap was for early humans. Fire, language, or something else entirely. I read them all, and it genuinely shapes what comes next. Subscribe if you want to be here when it does.